Quadratic functions, the big picture, transformations, and solving by factoring. So for quadratic functions, our parent graph is y equals x squared. I went ahead and plotted some of the basic points for us. 0, 0, negative 1, 1, negative 2, 4, 1, 1, and 2, 4. So when we connect this, it creates this U shape that we call a parabola. When we look at a quadratic in its general form, leaving spaces A, H, and K for all of the transformations, this is where they apply. The vertex is going to be affected by H and K, our horizontal and vertical shift. You just have to remember, just like before, H is always going to be the opposite sign of what it looks like because of that negative. The axis of symmetry is a new term, and that's the vertical line that passes through the vertex. It's also a line of reflection for the parabola. And it's always written as an equation, x equals whatever the x-coordinate of the vertex is. So, if our vertex is hk, our axis of symmetry will be x equals h, whatever that x value of the vertex is. Your horizontal shift is based on your h, the opposite sign of what it appears to be, and it's going to move it left or right. Your vertical shift is based on k, and it'll be the same sign as it appears, and it'll move it up or down. Now your compression or your stretch is based on the absolute value of a. So remember, it will be a compression if the absolute value of a is less than 1, and you'll have a vertical stretch if the absolute value of a is greater than 1. So then in looking at our parent function y equals x squared, let's go ahead and fill in our chart. Your vertex is going to be at the coordinate point 0, 0. Your axis of symmetry, because the x-coordinate of your vertex is 0, the axis of symmetry is x equals 0. Your horizontal shift is based on your h, so you're going to have none. And your vertical shift is also going to be none. Similarly, your stretch or compression, you have none, because we have a leading coefficient, our a is equal to 1. It's not greater or less than 1. Let's look at a few other specifics of our parent graph y equals x squared. The domain talks about our x values. So this u, or the parabola, is going to open to the left and to the right forever. So our domain is going to be negative to positive infinity. Now our range, the number that's going to help us out for our range is actually the y-coordinate of our vertex. When we look at our range, our lowest y value is 0, and it's going to go up forever into our positive values. So our range is 0 to positive infinity. Our increasing and decreasing intervals, the number that's going to help us out is the x-coordinate of our vertex. So from negative infinity until we get to the vertex where it changes direction, our parabola is decreasing from left to right. So our decreasing interval is negative infinity to 0. And then from x equals 0 out to positive infinity, this is where the rest of our parabola is increasing. So from 0 to positive infinity, we are increasing. Lastly, we need to take a look at our end behavior. So this is asking, as x approaches infinity, where is y going, our f of x? And as x approaches negative infinity, where is y going, our f of x? So end behavior, we're looking at the very ends of our graph. Now for parabolas, they're always going to go in the same direction, either both up or both down. In this case, they're both going up towards positive infinity. Next, we want to talk about how to solve a quadratic equation. And when we ask you to solve a quadratic equation, we're asking you to find the solutions, zeros, roots, or most importantly, the x-intercepts of the function. So x-intercept is a key word to remember because when you use method 1 for solving by graphing, whether it's looking at a picture of a graph or on the calculator, you are looking for those x-intercepts. That's what we mean by solving the quadratic equation. Now, if we're working on hand by paper and pencil, you can solve the equation for x when y is equal to 0. And there are 4 different methods we can use. We're going to go through these methods one at a time, but for this video, we're going to focus on factoring. So let me walk you through the steps of solving a quadratic function by factoring. You're going to get a quadratic function, and your very first step is to set your equation equal to 0. Now, this is an unspoken rule, but you want your x squared value to always be positive. So since x squared is positive, let's get everything on this left side of the equal sign. So we need to move the 18 over, so let's subtract 18 to the other side. This cancels out, so we have x squared plus 7x minus 18 equals 0. So we finish step number 1 by getting our equation set equal to 0. Step 2 asks us to factor the quadratic using one of the previously learned methods. So we've already learned multiple ways to factor different types of quadratics. So here we have a trinomial where a is equal to 1. So we're going to take the multiples of negative 18. So 18 is 18 and 1, 9 and 2, 6 and 3. And we need the multiples that are going to subtract to get positive 7. So positive 9 minus 2 will give us 7. So then we have a factor x plus 9 and x minus 2, and this is all still equal to 0. So now we've completed step 2. Step 3 asks us to set each factor equal to 0 and solve for x. So we'll take x plus 9, set it equal to 0, and solve for x. So we get x equals negative 9, and we need to do the same for our other factor. X minus 2 equals 0, solve for x, and we get x is equal to 2. So our final answer is x equals negative 9 and 2. That means that on our graph, our parabola is going to cross the x-axis where x equals negative 9 and x equals positive 2. Let's walk through a few more examples solving the following quadratics by factoring. Now, we've already walked through factoring a lot. So if you want, press pause, try to solve all of these, and then check back with me when you're finished to see how you did. If not, let's walk through these one at a time. Let's go ahead and practice 3 more questions. So to solve these by factoring, we have to first set the equation equal to 0. Since x squared is already positive, we want to add the 4x and the 3 to the other side. So we're going to have the equation x squared plus 4x plus 3 is equal to 0. And then when we find the factors of 3, that's easy. It's only 3 and 1. So we have factors x plus 3 and x plus 1, and that's still set equal to 0. So our next step, set each of these factors equal to 0, and then solve for x. So here we're going to subtract 3, so we'll get x equals negative 3. Here we'll subtract 1 from both sides. We'll get x equals negative 1. And those are our 2 answers, where x is equal to negative 3 and negative 1. When we look at example 2, our equation is already set equal to 0. Now in this one, we don't have that constant term, so we're just going to solve this by factoring out a GCF. So both of these terms have an x, so let's take out an x. So we're left with x minus 7 equal to 0. Now we factored this using a GCF, but the remaining steps are the same. We're still going to set each factor equal to 0 and solve for x. The nice thing is this first one is already solved for x, so here we just need to add 7 to the other side, and we'll get x equals 7. So our final answers, x equals 0 and 7. Don't forget that factoring by GCF is still factoring. Now in example 3, again, our first step is to set this equal to 0, so let's subtract 12 to the other side. So we have 2x squared plus 5x minus 12 equals 0. Now for this one, we do have a leading coefficient of 2, and it can't be divided through the rest of the function. So we're going to take 2 and negative 12, multiply them to get negative 24, and find the factors. 24 and 1, 2 and 12, 6 and 4, 8 and 3. Now the ones that subtract to positive 5 is going to be 8 minus 3. So let's go ahead and factor this by grouping. I'm going to rewrite this down here where I have some more space. We have 2x squared plus, and I'm going to replace that 5x with our 8 and negative 3, our 8x minus 3x minus 12 equals 0. So then from here, we can split this up, take out a GCF of 2x, so we're left with x plus 4. Here we're going to take out a GCF of negative 3, so we have x plus 4. Since these two are the same, we're going to take one of those factors, an x plus 4. Then we need to take our GCFs, 2x minus 3, and then we'll finish the rest of the steps. So we're going to take x plus 4, set it equal to 0. So we're going to subtract 4 from both sides, and we're going to end up with an x equals negative 4. Now this one, let me work it out over here. A 2x minus 3 equals 0. So we're going to add 3 to the other side. Then we have 2x equals 3, and then divide both sides by 2. So our final answer is going to be x equals negative 4 and 3 over 2. So these are our two answers found by factoring of example number 3. I'll see you in class for more practice.